Hello, welcome to another Feature in 5. My name is Jason Massae and I'm here with Cody Hosterman. Today we're going to look at the Space Reclamation and how simple it is from moving from a VMFS data store to vVols. So what are we looking at here? What do we see?
So we're looking at a Windows virtual machine that's filled with a bunch of data, right? There's almost 400 gigs of capacity being used by this particular virtual machine. And one of the benefits we've seen around vVols is that this space, the old dead capacity inside of the Windows machines or Linux machines, what have you, is stranded, right? If you delete files, if you move them somewhere else, the underlying layers don't know about it. You can see there's a lot of capacity being used currently by that particular virtual machine sitting on VMFS. And this is basically a design part around thick virtual disk. That space is allocated. Once you use it, it's being used. And so what we're going to do here is we're going to show what happens when you delete these files, right? Because that space is being used right now, but now that we've deleted all these files, cleared all the space up, there's no reason for the array to store this data anymore.
Mm-hmm.
Right?
And when we do the optimization, it doesn't work?
Exactly, because the virtual disk type is thick, right? It tells the guest OS, in this case Windows, that hey, I don't support unmap, right? And the VPD page is just saying this is not a feature I support, I cannot reclaim anything, and so Windows, in this case, or Linux or whatnot, cannot issue unmap, because these are features or trim that are built into the hypervisor. You can see it's built into OSs. You can see it says optimization not available, meaning that I don't see this as being supporting unmap, right? I can't run trim, I can't run unmap, I cannot reclaim the space. And so it sits there and it's stranded, and it can be stranded for a very long time. And this is one of the nice benefits around vVols is that from a pure perspective in this case, they're always thin. They always support unmap, and there's no allocation penalty on performance. And so you get all the cool stuff of thin, the flexibility and whatnot, but all the performance benefits of thick.
Yeah, I see we deleted all that data in that demo and nothing got reclaimed. Exactly. We're still showing the full amount of space being used.
That 386 gigs of storage is still being used, even though we deleted almost every byte of that from that particular Windows virtual machine. So let's move it to vVols. And what's the process to moving something to vVols? Storage remotion, all right?
Simple.
Do it live. So now that the virtual machine is being moved, and the cool thing about this is also going to offload that process via Xcopy. So it's an array-based move too, right? Even though that it's not vVol to vVol, it's still an array-based offloaded operation. And so we're going to restart this virtual machine. This process is what kicks Windows in to say, all right, let me relook at these virtual disks, these volumes, these file systems to see if they support unmap. So when it comes back up, Windows is going to say, hey, whoa, something's changed. This is thin now. I can run unmap. I can reclaim my space. So now that we're back in the rebooted Windows virtual machine, and we can verify, yeah, this capacity is cleared out, we can go back into Disk Optimizer.
Oh, yeah.
Look at that, right? It supports unmap. We can run optimizations because it's reported as a thin provisioned drive. So generally with Windows, this is an automatic process. Delete a file, runs unmap. With the original deletion, it didn't support unmap, so it did nothing. And so this is kind of backed up. And so you can run it manually or through PowerShell to reclaim the space. And you can see now, instead of that 386 gigs, it's down to 4.
4 gigs, wow.
That's like the boot, right?
Yeah.
The OS image of that particular virtual machine. And so this space has been reclaimed from the VMware perspective and reported back up. And this is one of the cool things around vVols too, is that the capacity reporting comes directly from the array, right? You can see this capacity came back, right? And that reporting is bubbled up into the VMware layer because it is now direct for each volume, right? It is directly reported what the array actually sees and preserves. And so there's no need for not only in-guest unmap, but there's no need for VMFS unmap because VMFS doesn't exist.
Yeah, you see the space was reclaimed right there. That's amazing. Literally just moving it from one data store to vVols.
Yeah, we've seen customers get 30% of their array back by moving everything from VMFS to vVols because it opened up unmap.
Wow.
Right? They basically, what happens, they moved them over to vVols. The next, patch Tuesday or whatever came around, they all rebooted, unmap kicked in, and bam, they got that capacity back.
Wow. Pretty amazing. Yeah. Just more testament to why vVols is amazing.
Agree.
For this and more, go to storagehub.vmware.com.